In previous lecture, we had started Unit 2 Network Theorems, and in that we had seen the points Kirchhoff's voltage law and Kirchhoff's current law, and we also solved problems on Kirchhoff's current law and Kirchhoff's voltage law. In today's lecture, we will going to see another example. See here, for the network given below, determine the current I, the unknown resistor R, and the voltage across each element. The figure is shown here, and we have to find out here current I. This is the current I. Then we have to find out the unknown resistor, means R3, and also we have to find out the voltage across voltage drop across each element, means across this, across R2 and across R3. So we will solve this. First we have to find out the total resistance, so that we can, it will be we had given the value of total resistance here, RT. We will see first the given quantities. RT is given here, R1 is given here, R2 is given, and we have to find out R3. As this is the series circuit, we can find out the resistance R3 by using the series resistance rule. So here RT is the total resistance, and if we write the formula for total resistance for series circuit, it will be RT is equal to R1 plus R2 plus R3, as this is series resistance. हे एक दिलेलं सेरीज सर्किट आहे, आणि सेरीज सर्किट मध्ये आपल्याला जर का रेजिस्टन्स फाइंड आउट करायचा असेल तर आपण तो कसा फाइंड आउट करतो, आपण युनिट फर्स्ट मध्ये पाहिलं. RT is given by, that means RT is here series resistance, total resistance. It will be given by the formula RT is equal to R1 plus R2 plus R3. Okay, in this formula we know the values RT, R1 and R2. The unknown is the R3, and we have to find out this R3. If we put the values from this here, we will get the equation. RT is given 16 ohm, R1 put it 5 ohm, R2 is here from the here 2 ohm, and R3 is unknown. So we will rewrite this formula for R3. We will get R3 is equal to here 16 minus 5 minus 2, means we will get R3 is equal to 9 ohm. 9 ohm, this is the unknown resistance. Okay. Next we have to find out now I, and also we have to find out the voltage drop across each element. So since all the resistors are in series, current flowing through each resistor is same. आपल्याला माहिती आहे, जर का सेरीज सर्किट असेल तर सेरीज सर्किट मधून फ्लो होणारा करंट हा सेम असतो, आणि तो या ठिकाणी I ने डिनोट केला आहे. अँड द व्होल्टेज ड्रॉप अक्रॉस 2 ओहम रेजिस्टर इज. मग यावरून आपण काय करू शकतो, तर आपल्याला या ठिकाणी व्होल्टेज ड्रॉप दिलेला आहे अक्रॉस 2 ओहम रेजिस्टर, इट इज 12 व्होल्ट. ओके, अँड वी नो द व्हॅल्यू ऑफ R2 हियर. R2 इज गिवन 2 ओहम. सो we can find out the voltage drop across this R2. How we can find out this R2? Here is the formula. VR2 is equal to IR2. म्हणजे सेरीज सर्किट मधून फ्लो होणारा करंट हा सगळ्या रेजिस्टर मधून फ्लो होणारा करंट हा सेम असणार आहे, आणि म्हणून कोणत्याही रेजिस्टरच्या अक्रॉसचा व्होल्टेज ड्रॉप जो आहे तो कसा दिला जातो, तर त्याच्यातून फ्लो होणारा करंट टाइम्स द रेजिस्टन्स व्हॅल्यू, म्हणजेच I into R2 will give us the voltage drop. आणि यामध्ये आपल्याला VR2 माहित आहे, तो दिला आहे या ठिकाणी 12 व्होल्ट. ओके, आणि R2 दिलेला आहे 2 ओहम. सो we can find out the unknown quantity here I. For I we can write here I is equal to VR2 divided by R2, that is equal to 12 volt divided by 2 ohm. We will get I here 6 ampere. Okay, this is the value of current, that is series current I. We have to find out the voltage drop across R1 and R3. So for that we can write the equation for voltage drop across R1 as VR1 is equal to IR1. Okay, so here VR1 is unknown but R1 is given 5 ohm and we know the value of I, that is 6 ampere, which we had find out here. Okay, R1 is 5 ohm, I find out 6 ampere, so we can find out here VR1. VR1 is equal to IR1. If we put the value into this equation, we will get VR1 is equal to, here I is 6 ampere into 5 ohm, means we will get VR1 is equal to 30 volt. And we have to also find out the voltage drop across R3, that is across 9 ohm resistor, and it is, we can write the equation for voltage drop across R3 as voltage drop across any resistor is voltage drop across any resistor is given by current flowing through that resistor multiplied by resistor value. So here current is I, as this is series circuit, so same current will be flow through all the elements. Okay, so the current will flow through this circuit is I and resistor is R3. So for this we can write VR3 as VR3 is equal to IR3, means if we put the value of I 6 ampere into 9 ohm, VR3 will be equal to here 54 volt. So from in this example we will get the results R3 9 ohm, which is the unknown resistor R. Then we get the value of I, it is a series current, we get its value 6 ampere, and the voltage drop across each element VR2 is given 12 volt and VR1 find out it is 30 volt and VR3 is 54 volt. Okay, now let us see the another example. Here for the circuit shown below, find V1, V2, V3. ओके, तर या ठिकाणी आपल्याला सर्किट दिलेला आहे आणि या सर्किटमध्ये आपल्याला काय फाइंड आउट करायचं आहे तर V1, V2 आणि V3 फाइंड आउट करायचं आहे. वेअर E इज इक्वल टू 30 व्होल्ट. हियर E, that is power supply voltage is given 30 volt. R1 is 4 kilo ohm, R2 is 5 kilo ohm and R3 is 6 kilo ohm are given. These are the given quantities. What are the given quantities? Given is the E, means supply voltage is given 30 volt, R1 is given 4 kilo ohm and R2 is given 5 kilo ohm, R3 6 kilo ohm. And what we have to find out here? We have to find out V1, V2 and V3. Okay, so first we will find out total resistance RT. As this is series circuit, हे एक series circuit आहे, तर आपण RT कसा find out करू शकतो? Just add the given resistors. So we will write the equation for RT. RT is equal to R1 plus R2 plus R3. If we put the values 4K plus 5K plus 6K, we will get the value of RT here 15 kilo ohm. Now we have to find out V1, V2 and V3. Okay, so according to potential divider rule, what is potential divider rule? In series circuit, the voltage drop across any element or any resistor is equal to that resistor times supply voltage divided by total series resistance. Okay, so from this rule we can write the equation for V1 as, what is the statement is the voltage drop across any series resistance means here R1. R1 च्या अक्रॉसचा व्होल्टेज ड्रॉप आपल्याला फाइंड आउट करायचा आहे. सो V1 इज इक्वल टू दॅट रेजिस्टर टाइम्स, म्हणजे ज्या रेजिस्टरच्या अक्रॉसचं व्होल्टेज आपल्याला फाइंड आउट करायचं आहे तो रेजिस्टर, त्या रेजिस्टरची व्हॅल्यू, तो रेजिस्टर म्हणजे R1, दॅट रेजिस्टर टाइम्स सप्लाय व्होल्टेज. सप्लाय व्होल्टेज इज हियर E, दॅट्स वाय हियर पुटेड E, डिवायडेड बाय टोटल सिरीज रेजिस्टन्स. मग टोटल सिरीज रेजिस्टन्स या सर्किटचा काय आहे RT, दॅट इज इक्वल टू R1 प्लस R2 प्लस R3. सो हियर पुटेड R1 प्लस R2 प्लस R3. Then we rewrite this equation R1 into E divided by RT. We put the values of R1, E and RT here. R1 is 4 kilo ohm, E is 30 volt and RT is 15K. Here we had find out. Okay, if we calculate this, solve this, then we will get here kilo ohm will get cancelled. Then 15 by 15 2s are 30, that's why we will get here 2 here, and 4 into 2 8 volt. So we get V1 8 volt. Likewise we can find out the voltage drop across R2, that is V2, and voltage drop across R3, that is V3. How we can find out this? Same formula, same rule we have to apply here, potential divider rule. What is potential divider rule? It states that the voltage across any series element, that is voltage across R2, is equal to that resistor times means R2 into supply voltage means E divided by total series resistance RT. ओके, तर आपण यावरून इथं हा फॉर्म्युला लिहिला आहे. मग इफ वी पुट द व्हॅल्यूज ऑफ R2, E and RT here, we will get the equation here 5K into 30 divided by 15K. If we solve this, then we will get here it is 10 volt. Okay, thus we get value of V2 is 10 volt. Now we have to find out V3. It is the voltage drop across R3. So how we can find this? Same. What is potential divider rule? The voltage drop across any series element is equal to that resistor times means R3. R3 into E divided by RT. Values here, then we will get here this 6K into 30 volt divided by 15K, and if we solve this we will get value 12 volt. It is the V3. Now here our problem is over, because what said to solve here we have to find out V1, V2 and V3. Now one additional thing we will do here, we will verify this circuit for KVL. What is KVL? Kirchhoff's voltage law states that the voltage rises must be equal to voltage drops, or the algebraic sum of voltages around any closed loop must be equal to 0. तर आता ते व्हेरीफाय होते का आपण पाहूयात. या ठिकाणी व्होल्टेज राइजेस काय आहे E, आणि व्होल्टेज ड्रॉप्स V1, V2 आणि V3, आणि हे एक क्लोज्ड लूप आहे. तर आपल्याला KVL व्हेरीफाय होते का पाहायचं आहे. व्होल्टेज राइज इज इक्वल टू व्होल्टेज ड्रॉप्स, सम ऑफ व्होल्टेज ड्रॉप्स. So E is equal to V1 plus V2 plus V3. If we put the values of these here, we will get 30 is equal to 30, means 30 minus 30 is equal to 0. Thus here KVL will be verified. Okay, so we will stop here. If you have any query, you can directly contact me. Thank you.